7.5 calls on this, expiring 21st of February. That means, and I got about, on average, 45 cents in option premium. So even though I paid $6 per share, I also got 45 cents for this. So my net cost is $5.55. And I'm going to renew these options in 3 weeks. If these options finish in the money, let's say on February 24th, this stock is trading at $9. I'm going to cry. Why? Because I committed myself to sell these things at 7.5. Yes, I still made some money. I bought it at 6 or $5.55 net. I'm going to sell it at 7.5. But I could have sold it at 9. Alternatively, in order to collect more premium, I could have sold performance above 7. I mean, currently, if you were establishing this position right now, you would buy it at $5.90. Let's do February 24th. You would get 20 cents option premium on 7.5, but on 7 you would get 30. On 6.5 you would get 45. So there's kind of a trade-off in between. The way I kind of look at these is I ask myself, what is the probability that I want this option to finish in the money, okay? Roughly speaking. If I look at this, it actually should tell me this one doesn't, but the app on my phone is going to tell me so-called probability of profit or finishing in the money. No, that's a different thing. Roughly speaking, the process as far as option prices are concerned is a return of, or is a drift rate, which means average annual return at the short-term interest rate and a volatility So this option I have on February 24th, it has how many days left? 11 days left, right? That is 0.031 years. Both the interest rates and volatility are annual numbers. So I need period drift and period volatility. Period drift, let's call it D. All right, let's just call it period drift. It's interest rate times T. So if it's 4% times 0.0301 or 0.12%. Period volatility equals sigma times square root of T, because volatility increases at the rate of square root. And if you had 2 years worth of data, and let's say volatility was 10%, volatility of the 2-year return is going to be square root of 2 times volatility of 1 year. And currently, this one has an implied volatility of 152%. Suppose sigma is, which is very high. That's why I like this strategy. 0.152% times square root of So we will act as if the 11-day returns or period returns are normally distributed between period drift and standard deviation of period volatility. So let's find out for 7.5, basically how many standard deviations is that above the current price. $5.90. Apply the period drift. And that's 590 times 1 plus 0.12%. It's not going to be much. So if my strike is 7.5, divide 7.5 minus 5.9071, oh, forget about that. $7.5. Current price is $5.90. That is a return of 7.5 divided by 590 minus 1, 27.12%. And I need to calculate the z-score for that. Z-score is basically that implied return. I'm going to use minus the mean, which is 0.12, divided by the period volatility, 1.02, okay?